Unit 2 dilation similarities and introducing slope end of unit assessment. Select all the true statements. Okay, dilations always increase the length of line segments. Well, dilation shape can get bigger or smaller or stay the same, so it does not always do that. Okay, dilations take perpendicular lines to perpendicular lines, meaning that if we have this T shape and we dilate it with a scale factor 2 around the origin, let's say that's the origin, it is now this big. My perpendicular lines are still perpendicular, so that is true. Dilations of an angle are congruent to the original. So all the angles in this and all the angles in this did not change. So that means they are congruent. Dilations increase the measure of angle. Well, my angles didn't change on my little drawing, so dilations of triangles are congruent to the original triangle. So if I have this triangle and I dilate it to a scale factor of 2, I now have this triangle. Angles are the same. It's just 2 times bigger. They are not congruent. They are similar. Triangles of similar, dilation of a triangle is similar to the original triangle. That is true. When you dilate 2 figures, they are similar. Which pair of triangles must be similar? So triangles 1 and 2 each have a 35-degree angle. Well, we only know one angle. We can't determine if they would be similar or not. Because we could have, I don't know, a 35-degree angle and a 105-degree angle, and then we can have a 35-degree angle with a 90-degree angle. So that does not work. Triangles 3 and 4 are both isosceles, and they each have a 45-degree angle. Isosceles triangle means they have 2 angles that are the same. So this could be 40, 40, and 40, 40 is 80. So 40, 40, and 100, which would be more like this. 40, 40, 100. Or this one could be 40, and it could be 70, 70. So that does not work because we don't know enough information. Triangle 5 has a 30-degree angle and 90, so there's 120. And triangle 6 has a 30-degree and a 70-degree angle. That's 100. So even if I add the 3 that I do know, I'm over 180. So that's not it. Triangle 7, well, that's the only one left, so it is it. But triangle 7 has a 50 and a 25. Triangle 8 has a 50 and 105. So if I add up the 3 angles I do know, they would need to equal 180, and they do. Not 1, there is no 1 to carry. Number 3, triangle ABC and DF are similar. So we have, let's say, original and new, or small and big. Small divided by big. When you divide those out, you should be having a calculator. You should use it. You would get 0.67. Long division would be, bring your decimal up, 2 times 6 is 12. 2 times 7 is 14. There's my long division. So going from old to new, you multiply by 0.67 or 67 hundredths. So to find out DF, you would have 4. We're going to just put 6.67 on the top. 4 times 7 is 28. Carry my 2. 4 times 8 is 24. Plus 2 more is 26. And we move decimal 2 times. So DF is 2 and 68 hundredths. BC, same thing. 67 hundredths times 3. 3 times 7 is 21. 3 times 6 is 18, 19, 20. 2 decimal places. 2 and 1/100th. Alrighty, back here. Select all lines that have a slope of 5 over 2. So that means I'm going to have a rise of 5 and a run of 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Over 1, 2, 3, 4. Is 10 over 4 equivalent to 5 over 2? It is equivalent to 5 over 2. B, 1, 2, 3, 4, 1, 2. No. C, 1, 2, a rise of 2 does not work. D, you have to make your own points, so you have to find your perfect points. 1 perfect point's here, and 1 is here. If this has a slope of 5 over 2, does that look similar? That's what you really should be asking yourself. This is my triangle. Does it look like it went up 5? No, so it's not D either. E, here's a point, and here's a point. 1, 2, 3, 4, 5. 1, 2. D and E are your only two. 5. What is the slope of the given line? You have to find your perfect points. It was harder. There weren't very many points to actually choose from. This right here, though, is a perfect point. And this right here is a perfect point. This one is a smidgen off. This one is a smidgen off. So those were the two actual perfect points. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So our slope is 5 over 4. What is the slope of a line that goes through 5, 6, and 25, 22? Show your work. Well, if I say these are my 1s and these are my 2s, I'm going to have y2 minus y1 over x2 minus x1. 22 minus 6 is 16. 25 minus 5 is 20. It can simplify to 4 over 5. If you would have done these minus these, you would have gotten 6 minus 22 over 5 minus 25. 5 minus 25. So 6 minus 22 gives you negative 16. 5 minus 25 gives you negative 20. Negative divided by a negative becomes a positive. And so it still simplifies to 4 over 5. Last one. Which of the polygons B, C, D, E, and F are similar to polygon A? So here's A. So D, some have said D was, but they're not, because then you wrote D was stretched. You cannot be stretched to be similar. You have to grow the same amount in every direction. F, the same thing happens. F stretched up. So it does not work. It doesn't even have the same slope, actually, because it should go through here. B looks bigger. So this is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So B, D and F were no's. So how would we get there? Because part 2 is choose one of the polygons to explain. So we're going to explain all of them. A to B. You can do any way you want. The way my brain goes first is to translate. Polygon A. G, wow, A. A. Down 1, 2, 3, 4, 5, 6. And right 1, 2, 3, 4. So now my shape is right here. So now we need to get 2 times bigger because it was 4 to 8. Dilate with scale factor of 2 with, this is S, S as center. Okay, next C. C looks similar. So we go from 4 to 2, and from 2 to 1. So that's half the size. A to C. Goodness. To C. So we would, having to reflect, so we're going to have to draw a line. Reflect over L. We're going to label it L. Translate, so I'm right here. If I reflect S over, S is right here. 1, 2, 3, 4, 5, 6, 7. 7 units right. Dilate with scale factor 1/2 because it got to half the size. Let's do at point S again because S is right here. Okay, so C was similar. E. E looks to be the exact same size. So you could have gotten patty paper, but you might not have. So A to E is a rotation. If you had patty paper, you could have done a guess and check to find your point of rotation. So let's see. It's gonna be up there somewhere. So it's going to be up in this area. So let's see. So here's my image. So, and I know I have to go this way. 90 degrees. So, let's see. That's where I thought it was. So, up 1. Over 2. So let's try that. Ooh, I'm getting closer. I think I went more than. No, it can be done. Okay, well let's just do it a different way. So we're gonna rotate counterclockwise 90 degrees Add S. So now we're right here. Translate down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 right. And that'll get us there as well. 8 was extra credit, so it's not going to be in this video.